And in today's class, we'll see the database machine initial configuration and cell administration and storage administration. So these are the topics covered in today's class. First, we will discuss few things about the configuration. Once the database machine is installed, there are some configuration steps that are done by Oracle team. Okay. Again, these configuration steps will be done during the initial installation and configuration stage itself. But as a DMA, who is responsible for managing this database machine, you need to be aware of all these configuration settings. These are the nuts and bolts that you need to tighten as required during the ongoing maintenance phase. Okay. Now, once the database machine is installed, okay, you need to edit some configuration files. You need to create some configuration files and edit them on the database servers so that database servers can access the storage servers. The question is, you have database servers, you have storage servers. How does a database machine know what storage servers it has and it need to access? So that is done through some configuration. Basically, on every database server, during the initial installation configuration phase, Oracle team creates two files. Those are named as cellinit.vara, cellip.vara. These are on the database servers. Okay, and they are created under a standard location, which is under etc Oracle, as shown in this slide. So the standard directory for these files is etc Oracle cell network config. So on every database server, you will have this directory. In our lab also, we have created this directory. So under this directory, there are two files, cellinit.vara, cellip.vara. Cellinit.vara has, okay, details about the network interface on the database server that should be used to communicate with the storage server. Okay, so on the database servers, we know there are many network interfaces. Okay, you have ILAM, you have InfiniBand, you have client access network like Ethernet interfaces. So out of these many interfaces, which interface should be used to communicate with the storage servers? So that interface details in the form of IP and subnet mask. So on the real hardware, this is obviously your InfiniBand network. Okay, because on the real box, InfiniBand interface is used to communicate with storage servers. So that way, now database servers knows with which interface it need to communicate to the storage servers. Then the second file, cellip.vara, contains IP of every cell in the configuration in this format. Okay, one line per cell. Cell equal to the IP address of the cell. For every cell, you have to mention this. So in the lab, okay, we have three cells. Okay, and in the lab, we use this IP series, right? This is actually in the lab I have 10 series, not 120, 192 series. So for every cell, you need to mention the IP. Just earlier compilations I have done with 192 series, but nowadays it is Okay. So that way these two files are very important. And suppose tomorrow you added one more storage server. You bought storage expansion rack and added to the cluster. So then you need to edit cell IP.vara to include the IPs of the new cells. Otherwise, the database servers cannot recognize the new storage servers. Then, apart from these two files, there are few other things, few other parameters at ASM level and database level that you need to set. Basically, when it comes to ASM, there is a parameter ASM disk string, right? So this parameter, okay, setting is used to discover Exadata grid disks, because in Exadata the ASM disks are nothing but your grid disks, but grid disks are on the storage server. So to identify the grid disks inside ASM, you need to set this parameter ASM disk string, and this parameter should be set in this format. The format is, standard format is O/cell IP address / grid disk name. Okay. So the example, whoever it is, can you please be on mute? Okay. Okay. So some examples: ASM disk string O/****. So this tells that the ASM instance has to, okay, search every cell. Star means every. So the second field is cell. So star means on every cell. Then the third field is grid disk name, means every grid disk created on that cell. Okay. So the default setting will be like this only. ASM disk string equal to O/****, means every grid disk created on every cell should be used, should be detected. If you want, you can customize that. Okay. For example, this one O/192.168.1.120. So that means you are telling you discover, okay, you include only this server in your discovery. Then on that server again, you are not using every grid disk. You are telling you discover only those grid disks whose name starts with the data. Okay. So the second one is more restrictive. Okay. So it searches only one server, one storage server whose IP is this one, and on that storage server also not every grid disk. The grid disk whose name starts with the data. Okay. So that way in customized configurations. Okay. Suppose we discussed the other day. By default, default configuration uses all the grid disks from all the storage servers. In a non-default configuration, you can split the storage. The first two storage server allocated to one database. The next two storage servers allocated to another database, right? So, or ASM cluster. In that case, you can specify which ASM cluster should access which is storage server agreed disks. So in that case, you use the second format, but this is the default format on the real machine. O star star. Then on every database that uses Exadata storage, you need to set the compatible parameter to minimum 11.2 because the minimum version supported on the database machine is 11.2. So every database on Exadata should have this setting. Next, when you create ASM disk groups on Exadata, again there are some important considerations, important disk group attributes that you need to use. This slide shows you how to create ASM disk groups on Exadata. It is similar, but it is same as a non-Exadata. But when it comes to Exadata, the red attributes, the attributes mentioned in the red color are must. Okay. So what are those? Compatible.rdbms, compatible.asm. These must be set to minimum 11.2. Okay. Then there is another attribute, disk group attribute, which is used on Exadata. Cell dot smart scan capable. Okay, this must be set to true. Then only your smart scan feature will be enabled for the data stored on Exadata. We can have different compatible settings. Yes, yes. See, these compatible settings can be different. Okay, but underlying point is both compatible settings should be minimum 11.2. Okay, if you are using different versions of the databases, okay, the RDBMS compatible must be the least one, and ASM compatibility should always be higher than RDBMS compatibility or equal to RDBMS compatibility. These are the rules surrounding these parameters. Okay, so what are those? Once again, both the compatible parameters should be set to minimum of 11.2. Then, if you are running different versions of the databases on Exadata, compatible.rdbms must be set to the minimum version. Okay, suppose you have 11.2 and a 12.1 database on Exadata, so it should be set to 11.2. And ASM compatibility should be always higher in the configuration, that is 12.1. And this attribute cell.smart scan capable should be always set to true. Then only smart scan will be used for the data stored on the disk group. If you don't set this and you have some data on this disk group, smart scan will not be used for that data. So you lose that advantage of smart scans. And the last one, which is in blue color, it is not compulsory. It is best practice recommendation. So Oracle recommends you to use 4 MB allocation unit size on Exadata, because this smart scan is optimized for 4 MB reads, not 1 MB read. The default AU size is 1 MB, right? So outside Exadata, we go with the default most of the time, which is 1 MB. But on Exadata, the recommendation is 4 MB because smart scan is optimized for 4 MB reads. Other than this, the syntax remains the same. Next, you can configure storage server to send email alerts, right? This is what we discussed earlier. So this configuration can be done during the initial installation phase or at a later stage. This slide shows you how to change, okay, the storage server settings to, okay, send email notifications. Basically, you should use alter cell command and type your SMTP server details as mentioned in this mail. And alerts can be generated. Alerts can be alerts can be generated for 3 different settings: critical setting, warning setting, and clear setting. Let me read some questions I am getting. Yeah, can we have different, that is clarified, different compatible versions? Yes, it is possible. The smart scan does the row filtering. Right then, why it matters at the block? What is this? Yeah, it reads 4 MB, okay, blocks. So the read is optimized for 4 MB sizes. Okay, instead of reading 1 MB, 1 MB, 1 MB, okay, it can at a time read 4 MB disk region and do that smart scan. Can we set the smart scan to false for some disks and for some disks as true? Yes, that is possible. So if you create multiple disk groups, you can enable, disable smart scan for a particular disk group. So it is controlled by this parameter only. When you create that disk group, you mention this parameter, right? Suppose for this disk group, smart scan capable equal to false, then smart scan will be disabled for this particular disk group. That is possible. Yeah. Okay. So this is how you configure email settings. Once you configure email settings, you can list them. Your list cell detail command will show you your email related settings in the output. Then you can start to stop the cell services. You can start to stop them individually or together. So this slide shows you how to, okay, stop and start individual services like MS, RS, and cell serve, or using a single command how to stop all of them and how to start all of them. There is no start command, it is always restart. The keyword is restart. Okay, so alter cell, shut down services, MS, RS, cell serve or all. Similarly, alter cell, restart services, MS, RS, cell serve or all. Now, next configuration is, as I told you earlier, there is a utility called dcli. Dcli is used to execute the same command simultaneously on multiple storage servers. Cellcli is a standalone utility. So using cellcli, you can administer one cell. Using dcli, you can administer multiple cells. But dcli needs some initial configuration. Okay, so this is what we are going to learn now. What is that configuration? How to do that configuration? Okay, so basically, dcli allows you to simultaneously execute a command on multiple servers. Okay, can be configured on cell servers, database servers, and between cell servers and database servers. You can use dcli on any server inside the database machine. Okay, though it is by default installed on storage server, okay, you can copy it to database servers and use on database servers also. And dcli supports all the cellcli commands plus even operating system commands also. Okay, so that is the advantage with dcli. So this slide shows you the steps to configure dcli utility. For example, I want to configure dcli on storage servers, and dcli is configured for particular operating system accounts. For example, you know, on every cell we have an account called cell admin. Now I want to configure dcli for cell admin account on storage servers. First you need to log in as cell admin user, create a file. Okay, that file can be named okay with any name. You can give any name, but the standard name is cell underscore group. In the lab I used my cells. Okay, so this file will have information about all the cells in the configuration. Okay, then once this file is created, this file can be again created under any directory. Okay, you need to generate SSH keys using cell admin. SSH keygen is the command. So this is same that you do in standard rack configuration, right, to configure SSH. Then the third step is you establish user equivalence using dcli-k command. Okay, it is a three-step process. Create a cell group file, mention all the cell details in that file, then generate SSH key for each cell, then use dcli to set up user equivalence. So once these three steps are done, your dcli is configured. Now onwards, you can execute commands on multiple cells. This configuration is a one-time task. Okay. Once this is done, every day you can use dcli. And this example shows you some. This slide shows you some examples related to dcli, which we saw earlier also. Yeah, see, for every user, okay, whichever user you want to use for centralized administration, you need to set up dcli for that user. Dcli is user specific. It is like SSH configuration in rack. We configure SSH for grid user as well as Oracle user. Okay, so for every user used for administration purpose, you can configure dcli. For example, you can configure dcli for cell admin user. You can configure dcli for cell monitor user. In fact, you can configure dcli for root user also. It is user specific. So this first example shows you dcli -c. You need to mention the cell names separated with comma. Then the command, cellcli command, that should be executed on all these cells. Okay. Then the second example shows you how to use that group file. Instead of typing the cell name on the command line, we created a group file which has the cell names, right? So in that case, you can simply say dcli-g my cells, then the cellcli command that need to be executed. And the third example shows you how to execute operating system commands using dcli. Okay, dcli-g my cells, then in quotes you have to mention the operating system command. Okay, so that way dcli is very handy utility using which you can execute the same commands simultaneously on multiple servers. Okay, so we have lab practices to configure dclay. In fact, you will configure dclay on storage server and also on database server. Okay. So next configuration is storage configuration. This is going to be the most important hands-on for you in the lab. Okay. And the examples that I mentioned in your material, okay, is purely for understanding the storage configuration on the cell servers. In real time, you will never do those steps because Oracle will do those steps. Okay, but in the lab, we are imitating, adding a hard disk, adding a flash disk kind of thing. But in real time, you never do that. Okay, these commands which are used here, some of these commands will never be executed in real time on the real box. So what we will do is, in the lab environment, you have 3 storage servers, right? And on each storage server, I have added 4 hard disks, 2 flash disks. Okay, 2 flash disks and 4 hard disks, and created cell disks on all of them and created grid disks. Then these grid disks are used to create ASM disk groups. Okay, and on the flash disks, I used flash storage to configure flash cache and flash log. Okay, now in this lesson you will learn how to add a new hard disk and how to create a cell disk, how to create a grid disk, how to use those grid disks to create your ASM disk groups, and finally how to use those ASM disk groups in your database. So you will start from the very beginning step of adding a hard disk and go all the way up to ASM disk group creation. So that way you will learn the complete process involved in adding a hard disk. Okay. Similarly, you will add a flash disk and then create cell disk. Then on the cell disk, you can create ASM disks, that is grid disk, or the cell disk can be used to create flash cache and flash lab. So in this lesson, we are going to do all these things. Okay. Now in the lab environment, you are going to imitate, you are going to mimic a scenario where you are adding an additional hard disk. In real hardware, you will never add an additional hard disk. Every server, storage server has 12 hard disks. Those are fixed. So in real time, a disk may fail, you will replace this, but you will never add a new additional hard disk. Okay. So in the lab, we are somehow imitating that, adding a new hard disk. And in the lab environment, all the hard disks devices are created under opt Oracle cell disks raw directory. So this is the directory where the disk devices should be created so that your storage server can detect them. And we are using Linux command dd command to create a device. Okay, and this is the syntax of the dd command. So this command, what we are doing is we are creating a disk device whose name is disk 11. and whose size is 1 GB. Okay, so BS equal to 1M, block size equal to 1M, and how many such blocks count is 1024. So 1M into 1024 is nothing but 1 GB disk. 1 GB disk. Okay, so let me see if I can connect it to the lab system. Somebody is telling they are not able to access. Yeah. So my system is fine. Sai system of 130. Yeah? Looks like your system is not pinging. Okay. Why don't you post that message to Euclid support? Okay. Okay, for now I posted to Euclid support. Okay, so let them check this. Okay, now I connected to database server. Let me SSH to the storage server. Okay, so on every storage server, let us start cell client. Okay, there are different commands that you can use, or okay, you can use the list_learn command, or this command is more relevant command. List physical disk where disk type equal to hard disk. So how many hard disks it is listing? 4. Hard disks are named as disk 01, disk 02, disk 03, disk 04. This is on first cell. Then on the second cell, disk 05, 6, 7, 8. Third cell, 9, 10, 11, 12. So on every storage server, I added 4 hard disks. Similarly, on every storage server, I added 2 flash disks, flash 01, flash 02. Okay, flash 01, flash 02. So this is the current layout of the storage server in the lab. 4 disks, 4 hard disks, and 2 flash disks. Okay. Now, where are these disk devices added? In fact, in the lab, they are all one single physical disk. These are all virtual disks. In real time, you will have separate physical disks, but in the lab, I have only one hard disk. Using dd command, I created disk devices which are virtual. So where did I create? If you go to opt Oracle, cell disks raw. Okay, so this is the directory where I created all these disk devices. Disk 1, 2, 3, 4, flash 1, flash 2. How did I create this? Using the dd command. Using the dd command as shown in this slide. Go to that directory, use dd command. dd is OS command, not exa command. Okay, this is standard Linux command. If you want more details about dd, you can man dd. Okay, and learn more about dd. So there is some fixed syntax, and we are creating 1 GB in size. Okay, are these kind of candidate disk like in rack? Do we need to change the header for all the disks? Let us, these are going to be finally your ASM disks. Okay, first you are going to add a hard disk. On a hard disk you are going to create a cell disk, then you will create a grid disk, then these grid disks will act as your ASM disks. So this way you can add your own disk. Once the hard disk is added, every hard disk is automatically detected as a LUN in Exadata storage server, right? So once you create the hard disk with the dd command, now you can list the LUN. It will immediately detect that disk as a LUN. So these blue lines are related to your added disk, which is disk 11. So these are the LUNs related to already created disks. These are created by me. Okay. So once the LUN is visible, now what you do on the LUN, you will create cell disk. Okay. Create a cell disk name, and on which LUN you want to create. On which LUN you want to create the LUN name. So from earlier step, you will get the LUN name and you will mention that LUN name here. So this way you created a cell disk on that LUN. There are different syntax, right? If you want to create a cell disk on every available LUN, this is the command: create a cell disk all hard disk. So what this command does is, it will create a cell disk on all the hard disk based LUNs. During the initial configuration, Oracle team will use this kind of command. Okay. Here we are going to create cell disk on a particular LUN. So that LUN name should be mentioned. So once the cell disk is created, you need to create a grid disk on the cell disk. So this slide shows you how to create a grid disk. Create a grid disk name. On which cell disk? Cell disk equal to the cell disk name. And you can specify the size for the grid disk. If you don't specify the size, all the free space will be used to create the grid disk. Okay. So all the free space on the cell disk will be used to create the grid disk. And the below example shows you some more commands, different ways of using these commands. Create grid disk all prefix data. So that means we are going to create a grid disk on all the cell disks, and the grid disk name will start with the data. It will automatically use data as the prefix for every grid disk created, and each grid disk size is 300 GB. Okay, so that way you can use different syntax. Now once this command is executed, you are going to create a grid disks on the cell disk. So before creating grid disk, you have cell disk, and after creating grid disk, each cell disk is logically partitioned into grid disk. Now this grid disk is nothing but your ASM disk. Okay, so once the grid disks are created, now you can go to ASM, connected to ASM instance. This is on the database server, remember, because ASM is running on database servers. Up to the earlier slide, up to creating grid disks, you will do in the storage server. Once the grid disks are created, then you connect it to ASM instance and create the disk group. Create the disk group. So you observe this syntax, create a disk group, okay, disk group name, redundancy, disk. Now you observe this string O star. Star means every storage server. But on every storage server, what grid disks to be used, whose name is starting with dev HD. Okay, whose name is starting with dev HD. Not all the grid disks. Whatever is matching with this. Then attributes I am mentioning, compatible attribute, then AU size and smart scan equal to true, smart scan capable equal to true. So this is how you start adding hard disk. Once a hard disk is added, it will be detected as a LUN, and once a LUN is detected, you will create a cell disk on the LUN. Then on the cell disk, you create grid disk. Then using this grid disk, you create ASM disk group. So that is how the storage is provisioned inside the database machine. You can repeat similar steps for flash storage also. Now you want to add an additional flash disk in the lab. In the lab I have added 2 flash disks. Now you want to add a third one. Okay. So again you follow the similar steps. You go to that standard directory, okay, and use dd command to create a flash disk, and I am naming it as flash 11, and its size is again 1 GB. Okay. Then once you create a flash disk, you should be able to see the LUN corresponding to that flash disk. Once the LUN is visible, you can create cell disk on that flash disk. Then once the cell disk is created, you can create grid disk. Okay. Then once the grid disk is created, you can create ASM disk group utilizing all these grid disks. Okay. So the procedure is similar whether you are adding a hard disk or flash disk. And sometimes you may land into some errors, some issues, especially when you use dd command. Okay, if this command fails, mostly in the lab, in my lab it will not fail. So far it never failed for any student. Okay, but when I go to corporate trainings, in other labs, because the systems are slow, the devices are very slow devices, this command sometimes fails. If this command fails in between, before completing, you have to restart that storage server, reboot that storage server, okay, before proceeding with any other step. Simply issue init 6, let it come up, then you continue. Okay, but in the lab it should not fail, hopefully. Any doubts on this part? This is the most important demo which will help you to understand the storage concepts. Probably after doing the lab exercises, you will get further clarity, more clarity on this part. Okay. Then next is storage reconfiguration. I told you the one command process allocates the storage in the form of, in the ratio 40-60 between data disk group and record disk group, or 80-20. These two are the standard, right? 40-60 or 80-20. Now, if you want a different split, suppose a customer want 50-50, or a customer want 70-30, a customer want 30, 20-80, 20-80 is standard, again 90-10. Okay, how to do that? That should be done manually, and this is called as storage reconfiguration. Okay, and this is an online activity. You can do online while the system is up and running, while the database is up and running. But it is time consuming, especially when you have more storage servers inside the machine, because you have to execute this procedure on every storage server, one at a time. So can be performed. Okay. First of all, what is this concept? Online storage reconfiguration. Storage reconfiguration reallocates space between data and record disk groups. You can increase, decrease data. Similarly, you can increase, decrease record disk group size. It can be performed online without downtime, time consuming, and you should have sufficient free space. Okay, because one disk group you may want to increase in size. To increase, you should have free space. Another disk group you may want to decrease. So for decreasing, you don't need free space, but to increase, you need free space available. So first, what we need to do is decrease the size, then increase the size. So when you decrease, you get some free space released. That free space you can add to the second disk group. For example, in this slide you can see initially data is small size, record is big size. Now I want to give big size to data. Okay, I am increasing the size of data disk group and decreasing the size of record disk group. That is the aim. Okay, so in this case, this is the procedure how to do that. Let me read that question. So the usable area to put the DB files is the size of the disk group data. Correct. That is correct. Okay. So how many files can be created, or how big a file can be created, is dependent on your disk group size. So for this, the procedure is outlined here. It is very simple and very logical, but only thing is it is time consuming. Okay, because you do on one node at a time, one storage server at a time. So first what you need to do is, suppose you are going to perform this procedure on the first cell. Okay, and for data disk group, for one particular disk group. First what you need to do, you need to drop the disks in that failure group. Okay, using this command alter disk group data, drop disks in failure group. Okay, which failure group? That cell failure group. So we are doing this activity on the first cell. So you are dropping the disks in data disk group on cell 1. Okay. So then you drop the data, the disks in the record disk group. Then you drop the disks, grid disks belonging to data and record. Then you create the grid disks with the new size as required. Then you add them back to the disk group. So what you are doing, you are taking the grid disks ultimately belonging to that cell. Okay, you are dropping the grid disks belonging to that cell from the disk group. Then you are recreating these grid disks with a new size. Then again adding them back to the disk group. Okay. So in this process, rebalance happens 2 times. First time is when you draw the grid disks from the disk group. Rebalancing will happen. So you have to wait till the rebalance is complete. You can see the rebalancing details in $ASM operation view. So once the rebalancing is done, then only you have to proceed with the second step. You drop all those grid disks belonging to that cell. Then create a grid disk with new sizes. Then add them back to the disk group. Again, once you add these back to the disk group, another rebalance will happen now, one more time. So you wait till the rebalance is complete. Now you are done on the first cell. Then again, repeat the same procedure on second cell. Go to second cell, okay, and drop all the grid disks belonging to the second cell. Then wait for the rebalance. Then create the new grid disks with new sizes. Then again add them back to the disk group. Again rebalance will happen. So that way you have to do the same procedure on every cell, one cell at a time. Procedure seems to be simple, but it is time consuming because 2 times for every cell rebalancing happens 2 times. When you drop the disks initially, then again when you add them back to the disk group. So ultimately, once you are done with this, your storage is reconfigured, your data disk group will be bigger and your record disk group will be smaller now. Okay, so we have hands-on for this. Step by step is clearly mentioned in the document. Carefully follow each step and you should be able to do the procedure. Any doubts on this? This is, I know it may not be clear to many of the, okay, at the first time. Any doubts? Anything you want me to clarify on this slide?
Yeah, Murali, quick question on this. Maybe I missed when you're explaining somewhere.
Okay.
So this is readjusting the, disk groups, disk group allocation on the grid disk, right?
Yeah, on the storage server.
So, readjusting means, do they have data in it or being used by the database right now?
Yeah. See what you have data in data under record currently. Okay. But you are dropping those ASM disks. When you drop, there is no impact on the database because you have mirrored this data. The mirror copy is available in other storage server.
Okay.
See,
so in other words, just like a regular one, we are taking off the LUNs and re-adding and letting it rebalance, right?
Yeah,
It's similar to that.
It is similar to that only.
Okay.
Okay. See, it is very simple. From ASM, you are dropping the disks belonging to a failure group. Now, you know in Exadata, failure group is created at the cell level. All the disks belonging to a particular cell will be in one failure group, right? So when I am doing on cell 1, I need to drop the disks in failure group cell 1. When I am doing this procedure on cell 2, I need to drop the disks in failure group cell 2. So we are dropping the ASM disks belonging to that particular cell only. Because ASM has mirrored the data in other cell, dropping the disks in this cell will not have any impact on your data availability. So once you drop the ASM disks, ASM starts, right, rebalancing. Let it complete. Then you go to storage server, drop all those corresponding grid disks and create them with new sizes and add them back to your disk group inside ASM. So in this slide, the first part, last part is done on ASM instance. The middle part, you see the command prompt is self-like. These steps are done on storage server. Okay.
Murli?
Yeah.
You said that there will be a mirrored copy, right?
Yeah.
So the changes will be synced with the mirrored copy when?
See, the changes when you take that ASM disks offline for some time. You took them offline for 1 hour, then brought those disks online. Okay. Then these online disks will be synchronized with the mirror copies. Because when you take the disks offline, the data in that disk is not updated, right? Only the data on the mirror copy will be updated. So when you bring them online again, now these updates should be applied to the offline disks also.
Okay. Okay, thank you, Murli.
Yeah. See, there are two things that should be very clear. When you take the disk offline, rebalance will not happen. Agree or not? Resync will happen when you bring them online. Okay? But when you drop the disks and add them back, it's not resync, it is rebalance now. Entire data should be copied to the newly added disks. So there is a difference between resyncing and rebalancing. In rebalancing, the entire mirror data is being copied to the newly added disk. Whereas in resyncing, the data is already there. Okay? So it will not add that data again. But whatever changes are done after taking these disks offline, those changes only will be applied. So obviously resyncing takes less time, rebalancing takes more time. And the resyncing happens when you take the disk offline and bring it online after some time. Rebalance happens when the disk is dropped and added back. Right? Agree everybody or anybody differs? Resync is nothing but recovery. Again, recovery is a different term. Resync is, see, you have two copies of the data, same data. Okay? One copy has the modified data, another copy doesn't have modified data. Right? So resyncing, what it does, it synchronizes both the copies. Recovering is slightly different. It is big term actually. Okay. So you lost the data, you restore from backup and do some procedures. That is, okay, recovery procedure. Resyncing is just updating the copy with the latest changes. But many people interchangeably use these two terms, but technically the meaning is different. Recovery is different, resync is different, rebalance is different. Okay. So best thing is you practice the hands-ons mentioned in the material. But when you practice, analyze them. Step by step what you are doing, why you are doing, try to analyze them. Then if required, we can discuss again in tomorrow's class. But in my opinion, this is the most important topic for you to clearly understand Exadata storage concepts. The hands-ons related to this topic are very, very important for you. If required, we can spend one more class on this. No problem. Okay. Now, recommended storage configuration. Oracle recommends you to use to create 3 disk groups, right? Whatever may be the storage, how big it may be, all that you need to do is create 3 disk group. One is data, second is reco. Okay, so for every database, you need just 2 disk group. Data stores database files, reco stores recovery files. Then DBFS DG. In Exadata, there is a 3rd disk group created, which is called as DBFS DG, which is used to implement something called DBFS, database file system. Right? And Oracle recommends you to use high redundancy for data disk group if your system is very business critical. Otherwise, you can go with normal redundancy. And stripe disk groups across all the cells and all the disks. Okay, so you use grid disks from every cell to create your ASM disk group. This is what we discussed the other day also. So when you use all the grid disks from all the cells, the data will be striped across all the storage servers equally. Okay. Then use IORM to manage and allocate IO resources. IORM is a feature of Exadata which is used to implement IO restrictions. Okay, so when you run multiple databases on the Exadata database machine, all these databases share the same storage. Okay, this may pose a problem. A database, which is IO intensive, may impact other databases. Okay, so in that case, how do you control IO resources of one database from other database IO resources. So for that we have IORM feature, which we will learn in future classes. Okay, we have dedicated class on IORM. So this is a recommendation. If you are running multiple databases, better implement IORM so that you can isolate IO related to each database. So these are the recommendations. Okay, then there are some alternate storage configurations possible. Like other day, I think Sai raised this question. Okay, by default, the default configuration creates grid disks on every storage server, and the grid disks from all the storage servers are used to create ASM disk group. That is the standard. That is what Oracle recommends. With that approach, you are striping the data across all the storage servers and across all the hard disks in each storage server. Okay, but there are some alternate configurations available for storage servers, like the ones mentioned in this slide. The first one, partitioning by cell. So in this case, what we are doing is, suppose I have 4 cells, 4 storage servers. I am allocating the first 2 storage servers to one database. Okay, and creating 2 grid disks, data 1, record 1. And the next 2 storage servers are being allocated to another database. Maybe for compliance reason, okay, you don't want to share the storage, right? So in that case, you can split the storage by cells. But in this case, what we are doing, you are losing that IO bandwidth. You are distributing IO between 2 cells only instead of all the 4 cells as mentioned in this slide. The second possible configuration is partitioning by disk. Partitioning by disk. In this case, you are using all the 4 cells for every database. But what you are doing inside the cell, you are partitioning by disks. The first 6 disks are allocated to one database. The second 6 disks are allocated to another database. Okay. So this is another possible storage configuration. Both are supported, but Oracle doesn't recommend these configurations unless there is some compliance requirement for you in the organization. So by default, every storage server will be used and every hard disk will be used for all the databases created on the database machine. Okay. So these are some possible storage configurations. So this is the essence of this topic, but this topic has many hands-ons. More than theory, there are many hands-ons. Let me show you what hands-ons are related to this topic. Now, last class you must have done up to 8, right? Database configuration assistant. 1 to 8 practices must have been done by now. Then for today topic, 9, 10, 11, 12, 13, 14, 15, 16. Many hands-ons are there for today's topic. Okay, so each step is documented. The only thing is, while practicing, try to understand. Those are simple only, but some procedures are lengthy. Try to understand. If required, we can discuss and debate in tomorrow's class. So everybody, are you up to date with respect to labs? Are you practicing every day, or just listening to theory and yeah? Try to practice. Otherwise, you will be out of sync. I will be teaching something. You will be practicing something. Okay. So any further doubts on today's class?